Hey guys, welcome back to the Stable Machinist. Today we're going to be getting on to part 2 of our welding video table. So the plan of action is we're going to get our fixture made up so that we can put our plates on and have everything equally spaced with minimal maths involved. We're then going to move on to actually drilling our holes and then finally mounting it to the wall. Do have to admit, after playing around with the design a bit and thinking a bit too hard about it, I have decided to buy my hinges, mainly because it saves time and it's just a lot easier. Bit of cheating, I know, but hopefully you guys can forgive me and we can move on with life. So we've got our little thread turned down. We're just about to put the thread in. We've got a nice little undercut, see if it'll focus there. Got a nice little undercut, little chamfers on there. Looking good. We'll just thread it up now. See how we get on. So we have our first one done. So the thread's been put on there. Got a nice little undercut, and hopefully, if I do this properly, oh, there we go. We have 2. So now all we need to do is skim our plate, put them in, and we're ready to start drilling. Right, at this point, I realised that the way I was planning on holding the base to drill on was not very good. And admittedly, I stuck with it out of stubbornness, which I shouldn't have done. So I just thought I'd cut to this, just me saying, we are changing it. I've left the point in where I realise I'm not going to be able to ever make this work. And you will hear from me in a minute. The jack even won't even be needed. So we're going to change the whole thing. So a bit of a waste of time. We're learning, you're learning, hopefully. But yeah, this is machining, I guess. So just whilst the saw's running and we've got 5 minutes, I thought I'd go over a bit about what I want to get accomplished with the channel, if that makes sense. So the whole point of this was to introduce people to manufacturing or machining in general. I'm very new to everything, I'm sure you can tell, but I just want to really get you guys involved. So like, leave a comment on a video saying something you want to see. Maybe you want to see more machining, maybe you want to see more turning or more welding, which again, you guys are driving the channel in the direction it's going to go, and we can try and make it happen. We can definitely work. I'm definitely going to do a lot more machining coming up, and I want to go over like the basics of machining a lot more. Driving, you know, sort of how to clock in a vise, how to choose the right tool, and why you would do this instead of that, or why I would do it, I should say, from my limited experience. And I want to make sure that that's going to benefit. So we're back on a new day. What we're going to be doing today is we're going to be putting our vise on the mill. We're going to be clocking it in, getting everything set up, ready to machine our 2 blanks which we cut the other day, so that way we can mount our plates on the machine. So we'll move over to the machine, we'll get straight onto clocking the vise in. So make sure that the bottom of the vise is nice and clean, as you can see it is. We know that our table is nice and clean, as we can see. So what we're going to do is we're going to try and line the vise up just about here. Roughly just line up with the middle. Don't have to, but I like to just because it's easier. Making sure that our parallel's nice and clean on all the faces it's going to be sitting on. It doesn't have to be flat to the vise, it's sitting like this. Yeah, it can be on an angle like this. As long as it's clamping nicely on either side, which they're ground, so it will do. And I'm just going to tighten it up on the vise, and we're good to go. So now what I'll do is I'll get we've got everything set up ready to machine. I think what's happened is when the bandsaw, because it's cutting right on the limit, when you see it, that big block hanging out the back, it's actually cutting over the limit, but we made it work. As you can see, it's cut a bit on the piss. So, I'm back. Again, at this point, what I've now realised has happened is the bandsaw blade has worn. So what that means is that it's not cutting properly, which is why it's so skew-if. So what I did, admittedly, because there was a lot of swearing and a lot of frustration going on, didn't record changing the bandsaw blade, but I will do the next time I change it because it's a good process to follow and watch. I changed the bandsaw blade, got that big billet back out, but because we cut it down, I put it straight back in. I recut everything and we made it a bit bigger, so that way it's going to sit a bit higher because we had the material to do it, and at that point I had the time to do it. And then I reblocked it up. So what you're going to see now is that process. So enjoy the rest of the video. You won't be seeing me again, hopefully. So, we have finished our blocking up. As you can see, everything is nice and parallel. Now, for our blocking up, I used a tool that I haven't used before. I've had it for a while. I got it so cheap, I thought I was buying the wrong thing. Now, this is a corduroy. Read the name of it, where we can find it. ASM 150 by 20 ripper. But if you can see, I think it should focus. They are inserts. Now this means that they can be changed when they go dull. So once you don't have to regrind the tool like you do with high-speed steel or throw it away like you do with carbide. These are little carbide inserts. They're double-sided, so one side wears, you flip, put the next side in. This tool, altogether, cost me probably about 50 quid. So this, okay, let's hope it focuses, is a wobble bar. Now what this does is it sits in our spindle like this, and we get it spinning, only at about 500 RPM, and we slowly bring it in. Slowly bring it into our part, and as it comes into our part, it will finish like this because it will start offset like this. There's a little spring in here. I'm not going to pull it because I don't want to break it. Little spring in here that's holding it in, and what happens is as it spins, as it gets pushed in, it centers itself up, and as this little bit here, this is 5mm thick, as this goes past the center point of the cutter, of the wobble bar, it knocks itself off center. It throws itself off because it's no longer spinning centrally, which means that at that point we have to stop, and using our D.I.Y, which is this thing here, this is a digital readout, we simply just press 0. It's going to be a bit loud, so I'm going to try and voice over, but we'll see. So, wind it in, and as it's winding in, you see, it starts to centre itself quite a bit. Even more. So it's almost there now. It's popped. We stop. Move over to our D.I.Y and 0 it. And now we're going to do our Y. Moving it in. Moving it in. Pop. So we've measured everything up, and what we've got is we've got 28.75, which is an imperial measurement converted into metric. We've got 14 mil on either side because metric. Why not mix them? I guess that's their thing. So what we're going to do is to find our centre point of this one, or the distance between from here to here. Can we see? Yeah. What we got to do, let's just write this down here. 28.57. If I said 7.5, I do apologise. My numbers have clearly got mixed up. So the total distance from here to here is 28.57 plus 14, because half is the same, yeah? So this total distance, just lost that, is 42.57. Now, we have, in our billet, where we set our wobble bar, we've got our centre down the middle of the block. So what we need to do is divide that by 2, which gives us 21.285. That is how much we're going to move our X from centre line to side before drilling our holes. And that way, they're equally 42.57 mil apart. Yeah? I feel like Dora the Explorer. We're going to get on with that now. I'm going to try and find my pen lid. I've got no clue where it's gone. It's probably fallen down a crack. So, enjoy. We'll see you when we start drilling. Very handy, this drill set. I'll show you. Presto, high-speed steel. So high-speed steel, so they can be reground, but 1 to 13 mil in half mil increments. We're going to need the 10.5 because it's an M10, so we just want to give it some clearance. We're going to pre-drill it with a 4 mil, and then we'll go up to an 8 mil. No, we'll pre-drill it with a 6 mil. Yeah, and then we'll put the countersinks in after that. So, we've got our 2 identical parts now, with our holes in, countersunk for our bores. Swab still left in that one. We also have 4 M10 bolts, 5 M10 T-slots, and finally our 2 dowel pins, which are going at the end. So, what we're going to do now, we're going to move back over to our mill. We're going to take off the vise we just clocked in. We're going to bolt these down with the Allen key. Then going to bolt these down, fly skim over the top, and lastly, put our 2 holes in for our dowels. And then we call it a quit. And in the next video, we're then going to move on to drilling our holes. Bit of a long process, but it's the way the cookie crumbles. Right, so here is the last tool we're going to be using on the job before it is done. And this is a Presto again, because very cheap, very affordable. Cutwell do a wide range of them, so big shout out to Cutwell. It is a thread mill. It's got a nice little spot at the bottom here, which means I can put it, see if I can get you guys over, into this thing here. This is called a spring-loaded centre. So what this does is once this goes in, I wind it down and it keeps it locked perpendicular to the hull, which means that our threads will look, or should look, really, really good. So what we'll do is we'll just wind this in, lock that in. I'll put some tapping fluid in just to make sure. Wind up, and I can see that the spring load's taking its time. Just start tapping away. Really awkward angle, but promise it's nothing naughty. And they should sit nice and flush. I don't know if you're probably not getting as excited as this as I am, but this is fixture attempt number 2, so I'm hoping all goes well. There we go. So what I'll do is I'll just, how am I going to do this? Can I do that? Can I pop it straight? Ah, result. So just bring it down. So those are dowel pins, nice and in place, sitting flush with what we're going to be sitting on, which means we can drill perpendicular with hopefully minimal risk. That's it for this video. Sorry it's led on to a part 3, but if you enjoyed the video and you're here, still here, you must have enjoyed it if you stayed this long. Please don't forget to give it a like if you enjoyed it, and if you want to see more of some youngish man pottering around in a little stable that he's using as a workshop, please subscribe, and look forward to seeing you guys' comments. Thank you very much.